Okay, so I'm hoping I can do the rest of this in one more review video, meaning I'm going to do quadratics and finding roots, which means that we're going to do the rational zero test as well. So we're going to do our best. This was a lot and a lot of material, so I want you to be ready for polynomials. So the next thing is finding the roots of polynomials. So we're going to concentrate on quadratics first, okay, and then we're going to go to all kinds of polynomials. So quadratics, we have three ways to find the roots. We can factor. This is the fastest way, but not every quadratic can be factored. We can complete the square. This always works, but sometimes you could get some really ugly numbers here. Or we could use the quadratic formula, which also always works. But you have to remember the quadratic formula. So if you don't remember the quadratic formula, then it's not so pleasant. So let's just take some, let's quadratic formula. I'll put that here. We're not really going to practice using that. I'll do one with you. That's negative b. So remember, this is x equals negative b plus or minus the square root of b squared minus 4ac, and the whole thing is over 2a. All of this is to find the roots. Okay, so I'm going to take just one quadratic and we're going to do all three with this quadratic, and then we'll do another one and we'll do all three. So let's say that we have, so first of all, solving for the roots. Is the same thing as saying where is y equal to 0. Okay. So let's take f of x is equal to, we're going to make it so that a is equal to 1 here. X squared plus 10x plus 21. Okay, so let's do quadratic formula first. So if we say f of x is ax squared plus bx plus c. Okay, so first you're going to identify a, b, and c. So a is your coefficient of x squared. In this case, we don't see a coefficient, which means that there's a coefficient of 1. B is the coefficient of x. So if we look here, b is equal to 10. Notice it's not equal to 10x. B is the coefficient of x. So b is equal to 10. And finally, c is equal to 21. So quadratic formula, the nice thing is that it's just a plug and chug. So we have negative 10 plus or minus the square root of 10 squared. Okay, I'm going to put that in parentheses because if it had been negative, you would want parentheses there. Minus 4 times 1 times 21. And this whole thing is over 2 times 1. Don't rush this. Even when you put it into your calculator, don't rush it. Do it one step at a time. So we have negative 10 plus or minus the square root of 100. And then 4 times 1 times 21. So 4 times 21 is 84. So we're subtracting 84 from here. Over 2. 100 minus 84, 16. Notice I'm doing this in a lot of different steps. Take it slowly. Simplify the square root whenever you can. So this can be simplified. So we're going to simplify it to 4. If this had been a negative number, then you would take out an I. You would simplify it in the same way that you would if this, if it were just by itself, square root of something negative. So this is negative 10 plus or minus 4 over 2. Now at this point, simplify it. You can. These are whole numbers. So either x equals negative 10 plus 4 over 2. Negative 10 plus 4 is negative 6 over 2, or negative 3. Or x equals negative 10 minus 4 over 2, or negative 14 over 2, or negative 7. And remember, we have 2 solutions, so we like to write it as a set. If you are somebody who easily gets confused between interval notation and the other notations, I would encourage you to write it in increasing order, but it really doesn't matter. Okay, so if you wrote negative 3, negative 7, that's fine. If you wrote negative 7, negative 3, that's fine. Okay, so that would be the quadratic formula. Completing the square. So there are a lot of different ways to complete the square. So if you've been looking online and reading stuff online, they might do it differently than I do it. I don't care how you go about doing it. Some people do it where they're working with both sides of the equation. I do it where I'm working with one side of the equation, so that I never get confused about setting something equal to 0. Okay, so here, remember, you're taking the a and the b term. You're dividing the b by 2. So when a equals 1, this is kind of nice. So you're start with this. Okay, that tells me that you know something. Inside here, we're going to put x plus 5. The 5 comes from taking b and dividing by 2. Okay. Then if you remember from class, there's always an extra piece that needs to be subtracted. So the extra piece that's getting subtracted here is 25. So that 25 comes from taking this b over 2 and squaring it. Okay, x plus 5 squared is x squared plus 10x plus 25. But this is only x squared plus 10x. So we want to get rid of the 25. So we're subtracting 25. This is always going to be a minus, because when we square this, we're always going to have a plus. A plus 5 times plus 5 is plus 25. If this had been a minus 5 times a minus 5 is also plus 25. So this thing that we have is always going to be subtracted. Okay? And then you have to carry down the c term. So we're carrying down the plus 21. Okay, your next step is just to combine like terms. So we have x plus 5 squared, and then minus 25 plus 21 is negative 4. Okay, and when we solve for this, we're just setting it all equal to 0. Okay, so we have x plus 5 squared. At this point, we've completed the square. Now we're just solving for the roots. Okay, so we add 4 to both sides. This gives us x plus 5 squared is equal to 4. Now at this point, we take the square root. So I'm going to put this in a different color so that it's really clear. When we take the square root, we have to do plus or minus. Okay, notice that's happening in the quadratic formula. In the quadratic formula, we have plus or minus the square root. So now that leaves us, I'm going to bring this up here. It leaves us with x plus 5 is equal to plus or minus 2. Now we subtract 5 from both sides. So we have x equals negative 5 plus or minus 2. And again, in this case, we don't have a square root, so simplify it, okay? So we have x equals negative 5 plus 2 or negative 3, and x equals negative 5 minus 2, or negative 7. So we get the same thing, x equals negative 3, negative 7. And again, if you wrote negative 7, negative 3, that's fine. Okay, so that's completing the square. And then the last one is doing it through factoring. So we'll use same quadratic. F of x is equal to x squared plus 10x plus 21. So when a equals 1, this is nice and simple. We just take two numbers. When we add them, we should get b. And when we multiply them, we should get c. And what's happening is if we take the two factors and we multiply those two factors, we're going to get x squared plus 10x plus 21 back. So you'll see that when we get to the end, why this is true right here. So our b in this case is 10, and our c is 21. I recommend that you start with the 21. There are very few factors of 21. Okay, but for 10, there are lots of different ways that you could get 10. So factors of 21 are 1 and 21, which don't give you 10, and 7 and 3. But 7 and 3 do give you 10. So we have 7 and we have 3. Okay, which means that then what we have to do is these are our factors. We have x plus 7 and x plus 3. And this is what I meant from before, that when you multiply this together, the x times x gives you the x squared. What gives you the 10x is the plus 7x plus 3x. So that's why we have the two numbers that multiply out to b. And what gives you the 21 is the 7 times 3. So that's why we have two numbers that multiply to c. Okay. Now we're going to set this equal to 0. So using the 0 property, we set each factor equal to 0. 0 property says anything times 0 is 0. So if x plus 7 equals 0, then the whole thing equals 0. If x plus 3 equals 0, the whole thing equals 0. So we could subtract 7 from both sides, we get negative 7, and we could subtract 3 from both sides and get negative 3. Okay. Okay, let's do the same thing one more time. Let's do it with one where we have an a that's not equal to 1. Okay. So let's say that we have f of x equals, I'll try and make these nice numbers. Sorry, didn't mean to do that. We're not going to have parentheses. Just thinking for 1 second. Okay, so let's take, this one is not, we're not going to do it using factoring. It's not going to be factorable. Let's take 2x squared plus 16x minus 5. Okay, so this one we're only going to do it using completing the square. Okay, so completing the square, okay, we're gonna, So when a is not equal to 1. So we're going to factor a from first two terms only. Okay, so take this slowly, listen carefully. So the 2 is going to get factored from the x squared, from the 2x squared and the 16x, which leaves us with x squared plus 8x. Do not forget to multiply, to divide the middle term by 2, okay? So 16x divided by 2 is 8x. Do not forget to multiply the second term by the a. It's not always 2. If this had been a 3x squared plus 16x, you would have to divide by 3, okay? And then carry down the c. Okay? Complete the square on what's in the parentheses. So everything else just gets carried down. You're kind of just ignoring it. So we have the 2. And I'm going to use brackets just so that we don't get a lot and a lot of parentheses in there. And we're going to complete the square on what's inside. So you take the b. So we have this. Okay. The b gets divided by 2. So we have x plus 4. Now we need to subtract the extra piece. So the extra piece is this 4 squared. So 4 squared is 16. So we're subtracting 16. Now we have completed the square on that. That's it. And we subtract 5. Okay, so we completed the square by taking the b, dividing by 2, and then subtracting the extra piece here. Your next step is to redistribute your a. Okay, so some things I've been seeing when you complete the square with an a that's not equal to 1. First thing is, some people forget to factor the 2 from the b term. I already told you that. Second thing is, some people seem to try and combine these first 2 steps. They skip this step. Do not skip this step, okay? This step, there is an x squared and there is a bx, okay? So there are 2 terms here. You haven't started completing the square yet, so there are no parentheses. Then your next term, that's where you have the parentheses and that's getting squared, okay? Now we redistribute the 2. So this 2 is getting multiplied by both of these. So that's something that people forget to do. They forget to distribute it to the second number. So please make sure that you do that. So we have 2 times x plus 4 squared minus 32 minus 5. So don't forget to distribute it here, okay? And then you just combine like terms. So that gave us 2 times x plus 4 squared minus 37. Now we're going to solve for the roots. So we set it equal to 0. So we have 2 times x plus 4 squared minus 37 equals 0. So we're going to add 37 to both sides. We have 2 times x plus 4 squared is equal to 37. Now remember, you're going to isolate what's being squared. So you have to divide by 2. Okay, I'm going to bring this to the next page, which leaves us with x plus 4 squared is equal to 37 over 2. Okay, and now again, I'm going to put this in a different color just so that you really see it. You want to take the square root of both sides. And when you take the square root, you can't forget the plus or minus. So that leaves us with x plus 4 is equal to plus or minus the square root of 37 over 2. And subtract 4 from both sides. So x equals negative 4 plus or minus the square root of 37 I didn't make the square root long enough. So the square root of 37 over 2. Now you can leave it like this for now. There's nothing that can be simplified here. Remember, you can separate the square root into the square root of 37 over the square root of 2, but you can't do anything with that. So you can leave it like this, okay? In the future, I would tell you don't put a square root in the denominator, but we're not talking about that for a while. So for now, this is enough, okay? If you could simplify the radical, then do, okay? Okay, let's take one, let's take another one and let's do it by factoring. So let's say that we have f of x is equal to 3x squared plus 7x plus 3. Okay, so your first step is going to be, so this is by factoring. You can do this using completing the square, okay? Completing the square always works, but you have a 7 here. So when you take 7 and you divide it by 3, because remember you have to take the first two terms and divide by a, this starts to get really messy because you have these fractions. And if you don't like working with fractions, completing the square, even though you can do it and it's completely possible, it's not that pretty. So for something like this, I would use quadratic formula or factoring. And if you think it's factorable, then do it by factoring, okay? Because factoring is the fastest, whereas quadratic formula, you have a lot of plugging in. So the first thing that you're going to do is you're going to multiply a by c. So if we do a times c, here, that's 3 times 3. Okay, your a is equal to 3. That comes from here. This is your a. And your c also happens to be 3. This is your c. Okay. So now you need two numbers that multiply to a times c. So how do you remember what they multiply to? You're multiplying a and c. So that's what they're multiplying to. Okay. And you need two numbers that add to b. It's the same two numbers. So in this case, your two numbers should be multiplying. I wrote 7. I meant 9. Just getting ahead of myself. Okay. You need two numbers that multiply to 9 and two numbers that add to 7. Okay. I did something wrong here. I didn't mean 7x. I'm going to change this middle number. Give me 1 second. We're going to make this 10x. It's just going to be messy otherwise. So I'm making that 10x. Okay, meaning you need two numbers that add to 10. Okay, it's going to be nicer numbers then. And this is 9 and 1. Okay, So now what you're going to do is you're going to replace your bx with these two terms. So if this is step 1 and this is step 2, step 3 says replace bx with the two numbers you found in step 2. Okay, in other words, f of x is equal to 3x squared. And now instead of 10x, you're going to use these two numbers. You're going to use the 9 and the 1. So you're going to write 10x as plus 9x plus x. And then the c just remains the same because we're only replacing the bx. Okay. And your last step is to factor by grouping. So I'm going to go over this here, and I'll go over it one more time with 1 cubic. Okay. So in order to factor by grouping, you divide this into 2 groups. Okay. So we're dividing it into 3x squared plus 9x and into x plus 3. These are our 2 groups. And you're going to pull a common factor out of 3x squared plus 9x. I'm sorry. Okay, so if we pull a common factor out of 3x squared plus 9x, a 3x is a common factor. So we're going to pull out 3x. And then we're left with x plus 3. And see how we have an x plus 3? There's nothing in common, so we're just going to take out a 1. Okay. We have an x plus 3 here and an x plus 3 here. So we're just going to pull out an x plus 3. We're going to bring that out to the front. And what we're left with, and that needs to go in parentheses. Order of operations. If it doesn't go in parentheses, then you're saying you're only multiplying the 3 by what's inside here. That's not true. You're multiplying the x plus 3. Okay. So what's left in the first one is 3x. And what's left in the second one is just a 1. Okay. So the 3x came from here. The 1 came from here. And if we were to multiply back, we would have x plus 3 times 3x, which is this. And then we would have x plus 3 times 1, which is this. And when we solve for the roots, we set it equal to 0. 0 property says either x plus 3 equals 0 or 3x plus 1 equals 0. So here, x equals negative 3. Here, we can subtract 1 from both sides. That gives us 3x equals negative 1, or x equals negative 1/3. And you can always check your work using the quadratic formula. Okay, so you can always check work. You don't have to trust yourself. Okay, so this is finding the roots by factoring for quadratic. Let's do 1 cubic, okay? So I want to do a factor by grouping for 1 cubic. Just so that you see how it works, and it's exactly the same thing as it is here, okay? So let's take an example. Okay, so for the factoring a cubic, we're going to do 8x cubed minus 20x squared minus 2x plus 5. Okay, and once again, we're going to divide it into 2 groups. I want to emphasize that not every cubic is factorable. Okay, factor is factorable by grouping. This is only some cubics. So we do the same thing. We divide it into pairs and we say in the first two terms, what's something that they both have in common? So they both have an x squared in common. Both of them are divisible by x squared, but they're also both divisible by 4. So we're going to take out a 4x squared from here. And what we're left with is a 2x minus 5. Okay, if we redistributed the 4x squared, we would get 8x cubed minus 20x squared. So you can always check by just multiplying back in. Now we're going to look at the negative 2x plus 5. Now if you see a negative here, pull it out. Okay, so we're going to pull out the negative from here. And we're going to make it plus negative 1, which leaves us with 2x minus 5 also. You know it's not factorable by grouping if you don't get the same thing in these parentheses. Okay, so if you don't get the same thing, if it's opposite signs, then double check and make sure that you can't pull out a negative 1. Here we see a negative 1, so we're pulling it out. Okay, so from here, we can pull out the 2x minus 5. And what we're left with is 4x squared minus 1. Okay, so the difference between a quadratic and a cubic is a quadratic you would be done right now. A cubic, you need to look at this and see if there's a difference of squares. A difference of squares says a squared minus b squared is equal to a plus b times a minus b. So we have to check for that here, and we actually have it. 4 is a perfect square, 4x squared is a perfect square, so is 1. So this becomes 2x minus 5. And then 2x plus 1, 2x minus 1. Okay, and if we wanted to find the roots from here, it would be x equals 5 halves. From here, it would be x equals negative 1 half. And from here, it would be x equals positive 1 half. So you always want to check if there is no difference of squares, then you just leave it. So if that had been a 4x squared plus 1, you just leave it. Okay, it has to be in the form a squared minus b squared. So this I went off the page by a little bit, so I'm just going to rewrite it here. I'm going to erase this and rewrite it so it's not off the page. So x equals 5 halves from there. X equals negative 1 half from here. And x equals positive 1 half from there. Okay. And we're done there. Okay, so the last thing, I'm just gonna go back and double check it's actually our last thing. Yes, it's actually our last thing. Our last thing is the rational zero test. Okay, and what this says is the possible rational zeros are equal to the factors of the constants over the factors of the leading coefficient. And I'm going to abbreviate that as LC. Over here, I'm going to say leading coefficient, but I just want you to know that throughout the rest of this, I'm just going to say LC. Okay, so let's just look at possible rational zeros. We're not even going to look at actually finding the zeros right now. So let's say, for example, f of x is equal to 10x to the fifth minus 3x to the third plus 7x minus 21. Okay. So the first thing that we want to do is identify the constant. So the constant is this last number here. Okay. It's not being multiplied by an x, it's multiplied by an x to the 0. So the constant is 21. It doesn't matter if it's positive or negative. So I'll put negative 21 because it's there, but we don't even have to worry about that. The leading coefficient is the coefficient of the term with the highest power of x. So our leading coefficient is 10. So now we just make our chart. We have the factors of the constant as our columns. And in our rows, we have the factors of the leading coefficient. So the factors of our constant is 21. So we have 1, 3, 7, and 21. And the factors of our leading coefficient are 1, 2, 5, and 10. So now we're going to put in the constant over the leading coefficient. So we're going to do column over row. So this is 1 over 1, which is just 1. 3 over 1, or 3. This is just 7. This is just 21. And they're all going to have plus or minus in front of it. So now we do our next row. So this is plus or minus 1/2. If you can simplify it, do. Plus or minus 3/2, plus or minus 7/2, plus or minus 21/2. Our next one is plus or minus 1/5, plus or minus 3/5, plus or minus 7/5, plus or minus 21/5. So far none of those could be simplified. And then finally, plus or minus 1/10, plus or minus 3/10, plus or minus 7/10, and plus or minus 21/10. These are all of the possible rational zeros. So we can figure out which one of these are zeros. Okay, we can do that in two ways. We can do it using the remainder theorem, okay, or really the factor theorem, okay, or we can use synthetic division. Let's take another example. Let's say that f of x is equal to 4x cubed minus 3x plus 12. Okay, so again, identify the constant. Constant is 12. Again, it's really irrelevant for this whether it's positive or negative because all of these are going to be plus or minus anyway. Okay, leading coefficient is 4. So we have the factors of the constant. The factors of our constant are 1, 2, 3, 4, 6, and 12. And then we have the factors of our leading coefficient. And the factors of our leading coefficient are just 1, 2, and 4. So now we're going to fill in the table. So 1 over 1 is 1, so this is going to be plus or minus 1. 2 over 1 is 2. 3 over 1 is 3. 4 over 1 is 4. 6 over 1 is 6. 12 over 1 is 12. We're going to do it for the second row. 1 over 2 is 1/2. 2 over 2 is just 1. So we have a repeat, so we can cross this out. We don't want to get confused and say, hey, we have an extra root. We don't. Then we have plus or minus 3/2. 4 over 2 is 2. And again, this is a repeat, so we just put an x through it. 6 over 2 is 3, another repeat. 12 over 2 is 6, another repeat. So notice there are 18 boxes here, but we don't actually have that many roots because a bunch of them are getting crossed out, okay? 1 over 4 is just 1/4. 2 over 4 is 1/2. So again, we have a repeat, so we can cross that out. Then we have 3 over 4. 4 over 4 is just 1, another repeat. 6 over 4 reduced is 3 over 2, another repeat. And 12 over 4 is 3, another repeat. So the number of roots is actually, we have the 6 up here, then we have 7, 8, 9, 10. We actually have 20 possibilities. So it's still a lot of possibilities, but it's 20 as opposed to 36. So it's a lot less, okay? Okay, so these are all of the possible rational zeros. So let's do one problem that works with the rational zero test. So suppose that we have f of x equals 5x cubed minus 16x squared plus 13x minus 2. And we want to do three things. We want to show that 1 is a 0 of f of x. Then we want to find all of the zeros. And finally, we're going to write the complete linear factorization. So that might be a problem that you see. I'm going to add in one extra piece, actually. We're going to do this table, okay? So to do that table, I'm going to do it right here. The constant is 2. That's our last number. Our leading coefficient, you can see, is 5. So this is a nice small table because the constant and the leading coefficient are both prime. So the factors of the constant are 1 and 2, and the factors of the leading coefficient are 1 and 5. So now we can just create our table. And this will help you see that 1 is a possible 0. These are not all zeros, okay? These are just possible zeros. If it's not in this chart, it is not a 0. So 1 over 1 is 1. So plus or minus 1 is a possible 0. So it's possible. So it's worth trying. Then we have 2. We have 1/5. We have plus or minus 2/5. Okay. So now we're going to do the first part. We're going to show that 1 is a 0. Now we have two ways of doing this. So I'm going to do it using both ways. You never have to use both ways. So using synthetic division. So I'm going to rewrite the polynomial here so it's on this page for you. F of x was 5x cubed minus 16x squared plus 13x minus 2. So using synthetic division, this is actually the most efficient way if you need to find the remaining zeros, but we'll do both ways. So 1 goes into our box. That's our 0. Our 0 is what goes inside this box, no matter what. Our coefficients are 5, negative 16, 13, and negative 2. We drop the 5. So we drop this first. This is a really slanted line, I'm sorry. We drop this first coefficient and we get 5. 5 times 1, so we multiply. 5 times 1 is 5. And then we add. So negative 16 plus 5 is negative 11. Negative 11 times 1 is negative 11. 13 and negative 11 is 2. And then 2 times 1 is 2. Negative 2 plus 2 is 0. So you can't just do this and stop here. You have to say it is a 0 because our remainder is 0. Okay. The second method is using the factor theorem. So this is another method. And this is just saying plug in 1. So 5 times 1 cubed minus 16 times 1 squared plus 13 times 1 minus 2. So 1 cubed is just 1. 1 squared is just 1. 13 times 1 is 1. Minus 2, negative 11, plus 13 is 2, minus 2 is 0. Our remainder is 0. Okay, so you can use either one of those methods. You don't have to use them both. The last thing that you're going to do, so this is C, is find the remaining zeros. So remember that this is your new quadratic. So you're going to find the zeros of 5x squared minus 11x plus 2. Okay, and the possibilities, so here, this is a quadratic. Try and factor it, okay? You can use the quadratic formula. You can use completing the square, although you're going to wind up with really ugly fractions if you use completing the square. Sorry about that. So I would recommend trying to factor, okay? Also, if you don't factor, then it's going to be a little bit harder for you to do the last part, the complete linear factorization. Not much harder, but just a little bit harder. Okay, so you're going to do A times C, because our A is not equal to 1. So that's 5 times 2, or 10. You need two numbers that multiply to A times C and add to B. This is what we did just before this. So these two numbers are going to be positive 11 and negative 1. So this middle term is going to be, wait, I didn't mean that. I meant positive 10. Sorry, negative 10 and negative 1. Negative 10 and negative 1. Okay. So what we're going to do is we're going to rewrite this middle term as negative 10x and negative 1x. The rest of it is going to remain the same. So we have 5x squared minus 10x minus x plus 2. Now we're going to complete the square. Not complete the square. Factor by grouping. So from the first two, we can pull out a 5x. And we're left with x minus 2. From the second two, we can pull out a negative 1. And you could just write this as minus 1. I'm setting it equal to 0. You don't have to set it equal to 0 at this point, but I am because we're going to be solving for the roots anyway. So we get x minus 2, and 5x minus 1 is what's left over. Now it asks to find for the zeros. So we have to set this equal to 0. We're not done. So I'm going to bring this over here so we don't run out of space. So that means that our remaining zeros are x equals 2 and x equals 1 over 5. Okay. Now, if you did quadratic formula, you would get this. So you would get the answer to this. It's the next piece that you might find a little bit harder. So the complete linear factorization, you're just taking from up here, you know that 1 is a root. So you have x equals 1. This is something that we did that I should go over too, but I'm only going to go over it here. X equals 1, x equals 2, x equals 1 over 5. So if you remember, we take this and we set each one equal to 0. Okay? So your factors become x minus 1, x minus 2, and 5x minus 1. So two of them are already up here. Okay? So it's just the third one, the x equals 1 becomes x minus 1. Okay, and let's actually just go over one example like that. I'm going to fit it in here just because I don't want to start a whole new page. I'm limited on pages. I'm using this really cool system where you have a notebook and all of the notes just get saved, but the notebooks have a limited number of pages. So I bought a certain number of notebooks and now everything is running out of the store. So I'm being very, I'm trying to preserve my pages. I hope that made sense. So let's say you have a polynomial with roots, with degree 5, and the roots are x equals negative 2, x equals 3 plus 2i, and x equals 6. Okay, and x equals negative 7. And we want to find the polynomial. Okay, so you wouldn't be asked to multiply this out in a case like this. So the first thing that we have to notice is that the number of roots that are given are 4, but we need 5 roots. Okay, the number of roots equals the degree. The number of roots equals the degree. Our missing root is x equals 3 minus 2i. Okay, that's the complex conjugate. So all we do at this point is we just make all of these equal to 0, and that's going to give us our factors. Okay, so hopefully this will all fit. X minus 2, when it's set equal to 0, becomes x plus 2. X equals 3 minus 2i. You subtract 3 from both sides, and you subtract 2i from both sides. X equals 6. You subtract 6 from both sides. X equals negative 7. You add 7 to both sides. And x equals 3 minus 2i. You subtract 3 from both sides, and you add 2i to both sides. And that's it. So this would be your polynomial right here. Okay, you wouldn't be asked to multiply. That's just a waste of your time. Okay, and just to be clear, I'm just going to box all of our answers in the previous one. So in the previous one, this is the complete linear factorization. Okay, if you were using the quadratic formula and this is what you got, then your linear factorization, you would see x minus 1, so same thing. You would have your roots, x equals 1, so you have x minus 1. X equals 2, so you have x minus 2. And you would have x equals 1/5, so you would think that you would write x minus 1/5. But it's a linear factorization, so you don't want fractions. You multiply everything by 5. And that's how you would get the 5x minus 1. So that's the difference with quadratic formula, is you don't want any fractions. Whereas in these problems, over here, it doesn't matter so much because we're not looking for a linear factorization. It's perfectly fine to multiply everything so that you don't have fractions. That's perfectly fine, but it's not as necessary as over here. Okay. Here our remainder is 0. We know that. Our roots, x equals 2, x equals 1/5. Remember, roots and zeros are interchangeable here. Okay. And that's it. That's all of our review. So that's a lot of review videos. I would suggest that you just fast forward through the things that you are 100% sure that you know. But polynomials is a huge part of this curriculum. So it's not a bad thing to just keep looking at it. It will be on the midterm in a couple of weeks. It will be on the final as well. Okay. Good luck. These will be posted. I will post a discussion on Blackboard. In that discussion section, I will post something for review videos. So it'll be one discussion for all of the review videos. Okay, thank you. I'll post the next video soon. That'll be on exponents and logs.